Good morning, good morning. We are talking today about lesson 1-8 in Glencoe course 2. And today's lesson is about slope. Now, believe it or not, slope is something that we already know about. We know how to calculate it. We know what it looks like. We just haven't done it yet, and we haven't called it slope before. So, slope is defined as the ratio between the vertical change, or the change in the y value, per unit of horizontal change, which is the change in x value. We can also call that the change in y divided by the change in x. So, there's multiple ways that we can write this. I'm going to write them all down for us at once. Slope is the change in our y value divided by the change in the x value. Now, I told you that mathematicians, we like to be lazy, correct? Correct. Okay, so instead of writing out change in all the time, there's a Greek letter that we can use instead. And that Greek letter is delta. And delta looks like a triangle. So we can say the triangle y divided by the triangle x. This means the exact same thing as this. But in this instance, we're using a triangle to represent the words change in. Okay? The slope is also known as the rise divided by the run. That means how far up did we go compared to how far over we go. How far up did we go, that's our change in y, divided by how far over we go. Any questions so far? No? Okay. Is there something else that we've looked at so far this chapter that compares how far up we went compared to how far over we went? What? Graphing. What did we graph? We graphed unit rates. And when we graphed our unit rate, did we compare how far up we went compared to how far over? Yeah. So is a unit rate another way that we can, is slope the graph form of our unit rate?
Yes.
Okay. And what was another way that we could call the unit rate? The constant what?
Rate. Oh, the constant.
The constant rate.
Constant unit. Constant rate of change.
The constant rate of change. Question? Okay. So, if we are told that the slope is the change in our y value divided by the change in our x value, and that is the same as saying delta y over delta x, because delta means the same as change in, and that is the same as looking at the rise over the run, or how far up divided by how far over. And that is the same thing as our graphed unit rate, which is the same thing as our graphed constant rate of change. Do we already know slope?
Yes.
Yeah. Are we just calling it something different?
Yes.
Yes. Do we need to be afraid of slope?
No.
No.
No, because we already know how to find the unit rate. We know what to look for when that's graphed. We already know what the constant rate of change is. We know how to find that. We're just calling it something slightly different this time. Now, let's look at example 1 on page 75. Example 1 on page 75. Example 1 on page 75 says what?
The table
Yes.
The table below shows the relationship between the number of seconds y it takes to get thunder after a lightning strikes and the miles x you are from the lightning. Graph the data and find the slope. Explain what the slope represents.
Okay, so okay. So, cafeteria. So, we have a table that gives us information and wants us to graph the data and find the slope. So, let's sketch a graph. Okay? We have our miles on our x value. We have seconds as our y. Okay? Our miles we count by ones up to 6. Our seconds count in 5s up to 30. Okay? So we have the point 0, 0. That means that in 0 seconds we traveled 0 miles. That's good. That means that the car is not traveling without us. Okay? At 1 mile, we have moved. We traveled 1 mile in 5 seconds. So I'm going to put a point here. In 2 miles, we went 10 seconds. In 3 miles, 15. 4 miles is 20. 5 miles is 25. 6 miles is not given. Okay. Do these points need to be connected? Yes. Okay. So we have a straight line. We have a straight line that is increasing and goes through the origin. So that means that this graph is what? Proportional. It is proportional. Very good. Which means that it can have a, which is a, which means that it has a slope. Good. Okay. How are we going to find our slope? Someone raise a hand and tell me. How are we going to find our slope based on this? What?
Put the little box thing.
We can. But we don't have to. How did I tell you that we could find our unit rate from a graph? We can divide, okay? So give me a set of data points that tells us that we can divide. Yes, sir. Okay, so 5 divided by 1, we're going to use this point right here. 5 seconds over 1 mile. What does 5 divided by 1 give us? 5. What are our units? Seconds per mile. Okay? So, if we have 5 seconds per mile, let's look back at our problem. It tells us to graph the data. Did we do that?
Yes.
Okay. Did we find the slope?
Yes.
Because our slope is also what?
5 seconds per mile.
Okay, so our slope is 5 seconds per mile, which is also called what?
Unit rate.
Which is also called what?
Constant rate of change.
Good. Now, did we explain what the slope represents? Have we done that yet?
No.
No. Okay, so what does this 5 mean? In the context of the problem, what does that mean?
5 seconds. 1 mile.
5 seconds per mile. Okay. 5 seconds per mile in terms of what? What are we talking about here? Are we talking about how fast we walk? Are we talking about the speed of a car? What are we talking about?
Speed like car.
What are we talking about? All right, we're looking at the distance between lightning and thunder, right?
Yes.
Okay. So, in the context of our lightning and thunder, what does this 5 seconds per mile mean?
That's right.
This means that for every 5 seconds between lightning and the thunder, so when you see the lightning to when you hear the thunder, that means that the eye of our storm is 1 mile away. Okay? Questions?
No.
No, we're good? Do we already know how to do this? Yeah. Are we just calling it something else? Yeah. Do we need another example? Give me thumbs up at your chest if yes, thumbs sideways, I'm not sure, thumbs down, no, I'm good. Okay, let's do one more. Turn the page to page 76. Turn the page to page 76. All right, let's look at example 2. Example 2 says, Ronaldo opened a savings account. Good for him. Each week he deposits $300. Ooh, I wish I had that kind of money. Draw a graph of the account balance versus time. So if we're looking at the balance, that means how much total he has in his account. Find the numerical value of the slope and interpret it in words. Okay, so we need a graph that has the number of weeks, and we have the total amount. Okay? So, the graph that's given to us has our weeks counted in twos. So we have 2, 4, 6, 8. And then the graph that's given, our y value increases in units of 600. Okay. Your graph has extra lines that I don't have, but that'll be okay. So, he earns $300 each week to put into his savings account. That means that after 1 week, how much money is he going to have? After 1 week, he's going to have $600? He's going to have $300. So if we count it in 600s over here, that means that this notch mark represents what?
300.
300. Okay? After 2 weeks, how much money should he have?
600.
After 3 weeks, he should have how much?
900.
900, which would be here?
Yes.
Okay. Can we keep going?
Yes.
Do we have to?
No.
No. Guys, at 0 weeks, how much money is in that account?
0.
$0. Okay. Should I connect my points?
Yes. Yes.
Yes? Okay. Is the graph proportional?
Yes.
Yes. What 3 conditions have been met? Give me one.
It goes through the origin.
Which is what point?
0, 0.
Very good. It goes through the origin, which is the point 0, 0. Give me another one. Yes, ma'am?
It's a straight line.
It's a straight line, which is the third. Yes, sir.
Increase.
It is increasing, which means that it looks like what? What does increasing mean? It means that it's going up. So our graph goes in an upward direction. Okay? Good. What is the slope in this situation? Because in this situation, were we given points? No, what were we given? What?
How many paid?
We were given how much money he puts in each week, right? Okay. Guys? What is our slope? What's our unit rate? week. How much money does he have? He has $300, so that is also our what? Our slope is 300. Were we given the slope in the problem? Yeah. We were given the slope this time. We weren't given data points. We were given the slope. And because we were given the slope, could we find data points?
Yes.
Yeah. So does it matter which one we're given?
No.
No, it doesn't matter. Okay? Now, ladies and gentlemen, let me ask you this. Let's say that his account started with $200 in it. Would that change our graph? Yes. Would that change our slope?
Yes.
Yes.
No.
Why not?
Because he's still adding in $300.
Right. So, when our graph is proportional, which is what we're going to be working with, our slope is the same. Okay? Sometimes, though, we can have a slope on a non-proportional graph. Does that make sense? No? Okay. So what we had, I said, let's assume that instead of having at 0 weeks, there was $0 in the account. I said, let's pretend that the account already had $200 in it. So at that point, would we have 0 weeks and $0?
No.
No, because he started out with $200 in it, right?
Yeah.
Okay. The bank was having a promotion. They said, when you open a savings account, we give you $200. So before he put any money into it, before week 1, he had $200. Okay? If you find that bank, let me know. So, in that situation, would the graph still be proportional? No, because at 0 weeks, he would have $200. It wouldn't go through 0, 0. But the slope would still be 300 because he was still putting in $300 each week, right? That would be the change. Correct?
Mm-hmm.
Okay. Are you with me?
Yes.
Did I just confuse you?
No.
Good. All right, ladies and gentlemen. Any other questions about slope?
No, ma'am. No, ma'am.
Now we're good?
Yes.
All right. Check my lesson plans for the homework for tonight or to see what problems we went over in class. Have a great day.